Okay, and a good morning to everyone. And that was John Denver. I recognize leaving on a jet plane. Not a bad idea. I'm ready for a weekend. A long weekend of grading. And that brings us up with the idea that we had a test, and that was returned to you on Friday. And you have an opportunity, if you weren't here, to watch the VHS tape at the reserve desk in the library. It'll cover the test and what we did in class. There was no quiz that we did following up the test. And just a reminder, we have some holidays coming up. So this Friday is a holiday, and because of that, we won't have the tutorial. And then Monday's another holiday, so that'll give you a chance maybe to get caught up on the homework, because these are some long, a little bit longer assignments in terms of the time I think they take. For those of you who did not take the practice test, I reopened that and left it open on Thursday until quite late. But some of you still didn't take it, and I think that's water under the bridge at this point. So should have maybe played Simon and Garfunkel, Bridge Over Troubled Water. So just a reminder, at each exam we have a practice test that becomes part of your homework grade. And so a few of you didn't finish up on that. We start with new material today. We're going to be in Chapter 3. My hope is to get up through 3.6 by the end of the week. Now, there's both new and old familiar material in here. In particular, there's a section on prime factoring of numbers that you'll find very familiar, and finding a greatest common factor. That's a little bit different than finding an LCD. But I think you'll find that pretty straightforward, and I may end up doubling up that section with another section as we go through the end of the week. It is at this point in this book that I suspect you start feeling like you're not in a pre-algebra, but in an algebra class. And you need to understand that part of our intent is to cover roughly half the Math 70 course as we cover the pre-algebra. Not maybe in the depth, but we're covering some concepts that should be typically found in a Math 70, and that's what we're going to do today. You recall that we talked about polynomials. We have monomials, binomials, trinomials, and what we end up doing in these sections is adding them, subtracting them, multiplying them, and factoring them. Now, what's not clear is why we want to do that. Let me put that in some context. Algebra is certainly a set of rules. You can look at algebra as just playing games with symbols and numbers. But algebra is also a subject area that allows you to solve problems. Okay? And the kinds of problems that we talk about in algebra are often given a kind of generic phrase, word problems. And we did problems very similar to what we do in algebra, in dimensional analysis, where we were asking how far you went, something of that nature. So let me try to put a little bit of this in perspective of what we want to have sections like 3.3, 3.4, 3.5, and 3.6. Why do we go through that? I'm going to try to put that in some context. Laritha had asked me in the 70 about consecutive integers. And in a sense, these are just problems that in beginning algebra are sort of recreational. Now, to say something's recreational means you should enjoy doing them. You should have fun. And I don't think that's probably what anybody doing these problems feels the first time they're doing them. But they give an insight into the power of algebra. And so we usually set up a statement like this, and you could do it without algebra. I'm thinking of two numbers. They are consecutive integers. And I'll tell you, their sum is 15. Now, just as a problem that you think through in your head, 2 consecutive integers, and the sum is 15. I hope you're coming up with 7 and 8. Agreed? Now, we can make the problem more complicated, but let's try to see how we would do that problem with algebra. I'm going to let x be one of the numbers I don't know. If they're consecutive, the other one has to be one more. So as I go to the board, we're going to look at a variable, which traditionally is x. So I'm going to let x equal the first integer. Then if I'm going to take the next consecutive integer, I just add 1. So x plus 1 is the second. And then I've said what? The sum, meaning you're going to add, must be 15. So I get an equation out of the statement. Now what do you have to do here to simplify this? Well, you have to add 2 polynomials, x and x plus 1. This is technically 1x, and this is 1x. And without making it more difficult than I think it is just by observation, that's 2x. So you have 2x plus 1 equals 15, and you've seen problems like this. Otherwise, we spent time doing a problem like that. You know you subtract 1 from both sides. When you get to this point, you know you divide by both sides by 2, and you get your solution. So if 7 is your first number, your next one's 8. Now, it's a very trivial problem. You can do it without the equations. But my point is, when you get expressions like this, and you have to add them together, you have to know how to do that. Or if I tell you the difference of the 2 numbers is 1, then instead of doing that, I would say x plus 1 minus x, okay, must equal 1. Because the difference of the 2 numbers, 8 and 7, would be 1. So I would have x plus 1 minus x. Okay, the difference of the 2 numbers must be 1. And if you think about that for a moment, x minus x is 0. Hold on. And we get this statement, and it so happens any numbers I want will work. 7 and 8, 9 and 10, 11 and 12, always works. Okay, I have questions. Michael, yours first.
Why did you say x plus 1 is the second integer?
Because they were consecutive.
Okay.
If the first one's 7, the next one must be 8. If the first one's 10, the next one must be 11.
Well, wouldn't you, couldn't you use another variable?
I could have used 2 variables. We will do that in an algebra class. But oftentimes in problems like this, I will use 1 variable. So it can be done with 1 or 2. In this particular case, I'm doing it as a single variable.
Okay.
And it's not that I expect you to know how to solve problems about integers. But I want you to note that this one seems reasonable, I hope, and that it involves adding 2 polynomials. And that's what we're doing. Here was a case of subtracting 2 polynomials. I had about 3 hands go up. Kim, we'll start with you.
Now, is it necessary to put the 2 under the 2 and 2 under the 14?
Yes, it is. At this point, I'd like you, the question is it necessary to show the division? I'd like you to do it right now, just to get comfortable with it. Later on, you'll say 2x is 14, x is 7, and you're done with it.
Yeah.
For the moment, a little bit of intermediate step I think is helpful. I don't know whose hand it was. Sandra, you have the most confused look on your face, so I'll take your question first.
I mean, I see how it makes sense how you got 7, but I'm just trying to figure out the intermediate step to how you got 14. Like, where do I go to get 14?
Up here, where I had 2x plus 1 is 15,
Yeah. So you do 15 minus 1? And
I subtracted 1 from both sides
Distributed property.
Okay.
to get 2x by itself. And we've done that step before. That's why I didn't show it. I thought that would be more clear than it appears to. Marisol?
I had the same question.
Okay, so why does that surprise me? Okay. So I answered your question as I answered Sandra's question. You didn't look nearly as perplexed as she did, though. Anybody else in that? Now, there are other questions of a similar nature that are a little more involved. For example, When you start doing these kinds of problems, and we're going to do applications as one of the sections next week, but they're problems about mixing liquids together. And so you have solutions. Oftentimes, you're looking at a solution stronger than you'd like. You have two bottles of something. One's stronger than you want, one's weaker than the other. So if you put them together, they should come out the right strength. So in the medical field, this is something that you're expected to do. If you're thinking in terms of problems about distances, we had the formula for distance equals rate multiplied by time as one of the formulas we did way back in the how much unit. I used that as an illustration. Well, we create word problems out of those. And some of them, as I say, are more recreational than useful. But as you go on in science, you go on into physics, you go on into chemistry, you go on into further areas in mathematics, these equations that I create, I need to know how to handle. So again, we want to be able to add, for the moment, and subtract polynomials. Now we're going to find that as we do this, in some cases it gets very tedious for what I'm showing, where you can look at x and add them together and get 2x. But technically, if I add these two polynomials, one's a monomial, one's a binomial, I can look at these unseen ones, and I can look at these two terms, and I can say, I can use the distributive property. And I can take out the x, and I have left 1 plus 1. That's x times 2, which we usually write as 2x. I defend this addition with the distributive property. To say that every time you add x and x, you have to go through the distributive property would be insane. You never get anything done. So there has to be a balance. Now, I haven't thrown out that 2. It's out here. And just to show you where we're headed, this is technically 2 times 1. So I have a 2 in common with both that I can take out. And that's called factoring with the distributive property. So this is a section we're headed to where we talk about factoring out a common factor. This is the largest factor that's in common to these two terms of this polynomial. So the language becomes very important as we talk about it. If every polynomial problem was this simple, we'd be done and we'd go on. That is not going to be the case. So as we look at 3.3, some of the examples, I'm just going to write a typical one on the board for a moment. Let's make 2 trinomials. So as we come over to the right a little bit, 3x squared plus 2x plus 1. And I'm not being very creative there, 3, 2, 1. I'm just counting down. And I want to add a second trinomial. And let's say it's going to be 2x squared plus 5x plus 3. That's a little more variety. And we'll just benchmark maybe to here. Now, in some ways, I more or less expect you to look at that and say, hey, I've got 3 of these, 2 of those. So I have how many of them? 5. And I can say 5x squared. And I have 2 of these and 5 of those, 7x. And I have 1 and 3, that's 4. And in practice, that's what we do. However, if that does not appeal to you, you need to understand that I could, through a combination of commutativity, associativity, I could ultimately get 3x squared, rearranging, plus 2x squared, plus 2x, plus 5x, plus 1, plus 3. All I did was rearrange. Kim?
Yeah, the second one?
This one?
Yeah, where you have 7x.
Yes.
It should not be 7x squared because you have 2 x's, so when that's
I
squared.
added, didn't multiply.
Oh, so only when you multiply a term squared.
Right.
Okay.
which I think you'll see here a little bit better before, and maybe this will get around your question. But Sandra, go ahead.
So then why did you put the 5x squared and then the 7x?
Because they're already squared.
Is it what?
They're already squared up there. I think that's why I'm not sure.
I don't huh?
Okay, I got a huh. Let me see if I can maybe help there. I had 3x squared and 2x squared, and I just combined those together. Now what I'm doing is rewriting it up to this point. As if, forget about the second line for a moment. Do you see what I've done here? Just rearranging. I brought the 2x squared next to the 3x squared. I'm adding them.
Yeah.
I brought the 5x next to the 2x because I was adding those.
Oh.
That's better than huh? Oh is better than huh?
I thought you were adding the ones just in the parentheses, so 3.
Well, I removed the parentheses. I could have. Okay, let's go one step further. I'm going to rewrite it this way. This, I hope, will make you feel much happier. I'll get out of the way so everybody can see it. I'm adding two polynomials, right? One below the other. Now is it maybe a little bit clearer that this is 5 of these? And this is a 7 of these? And then the 4? Now this is perhaps the clearest thing I can explain, but this is more typical of going from here to here without doing this. Okay?
Add what's in the parentheses first, and that's like a 5x squared.
But okay, I see your point. Do parentheses first?
Yeah, that's what I thought.
Okay, I see the concern, but there's nothing I can add in there because they are not like terms. Like terms, remember, have the same variables and the same exponents. Do you see how I rearranged this now from here to here, removing the parentheses? Again, I could defend that through community property, associative property, and about 5 or 6 steps. However, can't I take out the x squared because it's a common and have 3 plus 2 left using the distributive property? Remember, A times B plus C equals AB plus AC. Here is AB, I should say AB, AC. The A is in common to both, and I'm left with 3 plus 2. What would you get if you multiplied this out for me? X squared times 3 plus, thank you. So if that's what I get, I can reverse these two, correct? And replace one with the other. No, wait a minute.
I have to see it, I guess.
Okay.
Because I can't see it visually in my head.
Okay, let's take this over here as an aside. I have x squared times 3 plus 2 would be x squared times 3 plus x squared times 2. But we usually write the coefficient first. So we just reverse that by what property? What property? You do. X squared times 3 equals 3 times x squared, called the community property. Okay. 3x squared plus 2x squared. Do we agree? So if I can take this to here, I should be able to go from here to there. Reversibility. Okay, Debbie, back up to here now and bring that in a little bit tighter, just a little bit. So what could I do in the next one? Since there's an x in this and an x in this.
So x and then the 2 plus 5?
Yes. Okay, I've got Sandra convinced. Now what about the rest of you?
How would you do it for the last
I could take x to the 0, which would be a little bit overkill. So let's just go with 1 plus 3 is 4. But I could take x to the 0 out and have 1 plus 3 left, and so on. Now, is it clear that the 3 plus 2 is going to be a 5? So this is x squared times 5, which we would, by community property, write as 5x squared. X squared times 5 is 5 times x squared. A times b is b times a. 2 plus 5 is 7. X times 7 we usually write as 7x. Now we okay? Okay.
Underneath the first set is correct.
This one?
They're all correct.
Yes, they're all
I mean,
correct.
I'm saying if
They're
I-
all different ways of doing the same problem. This will result from this. This was the same as this. So the question is, how much do you need for an intermediate step to feel comfortable enough that as you see these problems, you can do them quickly without getting too bogged down? I would like you to be able to go from here to here. You may find it necessary for a while to put them one under the other and then do this. Okay? Now this is at an easier level, but this is a more efficient level, which you're going to be expected to do. Okay, let's change it slightly. Okay. I'm just going to come over and rewrite these, Debbie, and try to crowd this all in the space I have. Okay? Now, before I do anything else, I want to take a look at what I'm doing in the book so I don't go too far off the beaten path. I know how I would do the next step, but I want to see what the author's doing. So I'm going to come back center. And Chris, that's what I was talking about, what we're trying to achieve there. In this process, on page 175, as we get ready to go to the document cam, here is the kind of polynomial subtraction I'm doing. Now you'll notice it has been stacked. I think that's the phrase the text uses. We stack one below the other, but notice you have to be cautious because notice here that minus sign. Well, I can hardly see that minus sign on the television. Is that there? Yes. Notice where it's put here? That is dangerous because it looks like the 2 has been changed, but nothing else has, correct? Yeah. So you need parentheses nearly right after that minus sign because that says take the additive inverse of all that garbage or treat it as minus 1 times all that garbage. So I'm now going to go to the board. So in a way, what I would do and what I would explain are slightly different areas. I would prefer to look at this and then say, I have plus minus 1 times this trinomial. Now, when I multiply minus 1 times this trinomial, I can use the distributive property. And every sign will change in the trinomial. Because I'm multiplying by minus 1. Minus 1 times a term gives you the additive inverse. Now, I don't usually write that step. Here's what I do. I simply change the sign of everything in the second trinomial. Now, I could go back and say, well, this is plus a negative 2x squared, plus a negative 5x, plus a negative 3. In reality, I'm hoping you can say 3x squared minus 2x squared is x squared. Yes or no? I'm looking for Marisol. You have a look now.
positive plus a negative, and then they're both 2. So negative 2 plus positive 2.
What Marisol's saying, if I take this 3x squared and I have minus 2x squared, I could treat that as 3x squared plus a negative 2 times x squared. Would you agree? Marisol's not wanting to agree with me. Okay? Can you give me a little more space, Debbie, this way? Thank you. Now, what I'm going to do, and if I'm in your way, my apologies, but look at the monitor. What's in common to both of these now, Marisol? The x squared. So I can take that x squared out and have, by the distributive property, 3 plus a negative 2, which just becomes 1, right? So I have x squared times 1, but that is the same as 1x squared, which is the same as x squared by the identity property. Hence, x squared. Yes? Okay, I'm still looking for confused looks. Every time I try to explain one thing from one person, it seems like I get 3 more looks of confusion. Kim.
Well, I was understanding it.
Until I did this?
Uh-huh.
Then don't look at that and come back up here. 3 minus 2 is 1.
Yeah.
So I have 1x squared and you're okay.
Uh-huh.
Good. Okay, now, if I have 2x minus 5x, what should I get? Does negative 3x work okay, Kim? Everybody else? Without showing the distributive property in between. So we've got a negative 3x. Okay, I'm just looking at Sochi. Okay. Ephraim? Okay. I could do this, or I could do what instead? Just say x squared minus 3x. X squared plus negative 3x is the same as x squared minus 3x. A minus b is the same as a plus negative b. Hence, I could write this simply as x squared minus 3x. Not according to Sandra's eyes.
Yeah.
Okay. Sochi? Okay. 2x minus 5x is negative 3x. I will wait for Marisol's explanation.
I think you're a good teacher.
Thank you. We're just waiting for the extra help to finish. I can't tell if it's Marisol, you're fired. Sandra, you got it or not? What question do you have in your head?
I don't. So what is the answer? What am I trying to figure out?
What this all simplifies to, and 1 minus 3 is negative 2, which we would tend to write that way. Final answer, which Sandra seems to be wanting. X squared minus 3x minus 2.
How do you get the x squared?
Yeah, what part of it? All this part right here.
Yeah, and this. Wait, this.
Oh, those two.
But it was a Z, Emily, I'd have a little line through it. Okay. Picky, picky, picky. If that's the only thing that's bothering you, I feel very good. Sandra.
So basically, you're just adding the inverse?
Yes.
Because you just plus and you just change it to minus.
Yes.
Okay.
That's what this says.
Additive inverse.
But I can start here and go there, which is all I'm doing.
Additive inverse.
However, okay, Debbie, migration time. Me and the geese. Okay. Yes, Sochi, before I migrate. You want me to get out of the way so you can see what's there?
Yeah.
Okay, I'm gone. Okay, which part is it you have a question on? here? You okay there? You okay to here? From here to here? Those mean the same. Soshi?
It's a little confusing with the negative one up in there for me.
You don't like that negative one.
That confuses me.
Okay, I'm leaving that there for a moment. Let me go to an alternative. You're finding different comfort zones. So let's leave that on the board or on the screen for a moment, Debbie. So I can rewrite it 3x squared plus 2x plus 1 minus 2x squared plus 5x plus 3. Okay, we can cut to the board. Okay, this is for those of you who don't like my minus 1. We do nothing to the first, and I simply take the additive inverse of everything in here. Minus 2x squared minus 5x minus 3. Changed every sign. Kim?
With the negative in the middle, change to a plus.
Okay, Debbie, camera 1, right side where we were, where I have an A minus, yeah, that. I did change it to a plus, a negative 1. Remember, I could change from that minus in the first line. So this minus here in the first line, I treat it as the addition of the inverse. Now, I could have, instead of putting minus 1 there, just put a minus sign where my hand is. That would have done it also, which says the additive inverse of all that. That work better? Okay, back to the sideboard, please. So what I could have done, could have, would have, should have kind of thing, I will rewrite this up here as 3x squared plus 2x plus 1 plus the additive inverse of 2x squared plus 5x plus 3. What I'm really using here is the additive inverse of a plus b plus c is negative a plus negative b plus negative c. That's a kind of theorem, a statement I could make. Now, once you get to here, is it clear that 3x squared minus 2x squared is just x squared? 2x minus 5x is just negative 3x? And 1 minus 3 is just negative 2? That better? We're still getting the same answer. One more way. Now, this is what the text is doing, and this is where you've got to be careful, and you're going to do this in what we call long division of polynomials. Now, I really put that minus sign about as far as Debbie will allow me without going off the screen. Right? It means subtract. So what's our rule going to become? Change the sign of everything in this second row and add. Okay, this was a plus, so it'll become negative. This was a plus, it becomes negative. This was a plus, it becomes negative. And now add. 3x squared plus negative 2x squared is x squared. 2x plus negative 5x is negative. I'll do this still. And a plus 1 plus a negative 3 is plus a negative 2, which we rewrite this way. Now, you will do a lot of problems like this when you do long division of a polynomial into a polynomial in Math 70. Don't sit there, and this is where there's a certain thing you shouldn't do. You shouldn't try to write through the plus sign with the negative sign. What you do is you put in parentheses the sign change and then proceed to add. Now, that's about 5 different ways of trying to explain one problem. Okay, I'm going to leave that there, Debbie. I'm going to go back center and hope that this is making sense. Okay. As we look again at the document cam, remember my concern was this minus sign looks like you're doing what? Just getting a minus 2x squared. I think that sucks. There needs to be a parenthesis there. But what is done in the next step is change that to an addition of each inverse. And that's exactly what's done here. The only thing I don't like is instead of leaving it, I went plus minus 5x plus negative 4. That may be overkill, but it's the same process. Now, as I come off there and come down to here, the point is there's opportunity to do problems in the text and read. This is still at the bottom of 175. This is the same thing we just talked about. Now, notice, Kim, we could have gone plus the inverse of that. Well, the author skips the plus the inverse of that and just goes to the inverse. You like this, like here? Then buy it. Buy it. Put it in the freezer, keep it there forever. Okay, off of that. Is there anything worse? If you like another explanation, this one's pretty good. If you're hunting for something you can sort of follow through, I like the arrow stuff that's going on here. As you look at page 176, this may help you, where you see the minus sign in front of the trinomial, and then it becomes what? Plus a negative 3x squared, and you get some nice minus signs being shown with the arrows, and then going from here to here without any intermediate step. So I'm hoping that works for you. The concern is what happens if you have negative values. So coming off there for a moment, Debbie, I'm going to come down to this one. And this is where there's a little more concern. Okay, this is still on 176, and look at this one with a minus sign, and inside the trinomial we have what? A negative sign, which is going to become a positive when you take its inverse. So you have to be very careful of the switching of these signs, and you'll find the real emphasis here is on what? A linear presentation rather than stacking them. Now, if you look at the linear method and it's not working for you, don't feel badly about stacking them. That may be necessary to make it work for you. The mess we see on page 177 and 178, there are a lot of them. They go up through a total of 90 problems. So what I'm going to do is go to 179. Let's block this off here for a moment. Let's see if I can do this. Okay, let's just cut to there. There's my original problem. I don't want an intermediate step for a moment, just to look at it. Now that's one just like we looked at. And notice it is at the end of the set. So what are you going to do with the problem? Try writing out what you think the solution be, just on paper for a moment. Try writing it out. So you have x to the fourth minus 6x squared plus 3x. Then you're subtracting off an x to the fourth plus 2x cubed minus 4x. There's a couple things going on in this problem that make it a concern. I don't want to do that. I'm trying to figure out how I can hold that and not have it. There we go. Now this, I'm sort of taking the worst case problem to illustrate a point because there's some things here that may bother you. So let me write it on the board also while Debbie still has that on the screen. I have x to the fourth, then I have a minus 6x squared, I have a plus 3x, and a parentheses around that mess. Then I have a subtraction, another x to the fourth, a plus 2x cubed, which is the first wrinkle, and a minus 4x. Trap time if you aren't careful. Okay. First comment. What is your preference here? Do you have a group preference, or is it an individual one that I can't generalize? What do you want me to do? Next step.
What you end up with, like, what you just straight jump to, instead of going through all that garbage.
All that garbage. What do you want me to do with the next step, Sandra? What would you like me to do? You tell me.
You don't even need the x, right? The x to the fourth?
Oh.
Because you have an x to the fourth right there, and then that would be negative x to the fourth.
Okay, so it's going to disappear and go to 0. Yes. But I still want an intermediate step.
Oh.
Sorry.
Okay.
What do you want to do? Just going to go ahead and take the additive inverse of each part there. Write it all down then. So I have x to the fourth minus 6x squared plus 3x minus x to the fourth. Now again, the point that Sandra was making, that goes to 0, but I'm still going to write it down. Minus 2x cubed plus 4x. Now notice I just changed the signs. Soshi. You okay?
No. Can you do negative to positive? I mean, the minus sign to a
The
plus.
minus signs become positive. At a minus, so that became positive. This positive became negative. This was technically a plus here. It became negative. It just flips the signs.
Oh, okay.
Minus outside flips every sign.
Yeah.
Ready to go? Okay, so x to the fourth minus x to the fourth is just 0. Now, what should be listed next? These are not like terms. That's the trap. That's the trap. So you write negative 2x cubed minus 6x squared. Now what can I do? Plus 7x. Descending order. The 3, 2, and 1. Descending order is usual. Tricky problem. But what happens if you put it in stacking them up? Because that's where you have to be careful. So let's stack them. Just let you look at that for a moment. That's a very bad looking x to the fourth. Okay, Robert. Do you see what I did? Placeholders. I needed a column for the x cubes. I didn't have an x cubed in here, so I made a placeholder with 0x cubed. I didn't have an x squared in this one, so I needed a placeholder, so each place value, oh, I can't pass that up, each place value lines up. Robert. Hold on, not in the book yet.
No, I mean,
Michael,
it's the same problem.
I'll be with you in a minute. Michael. Okay, let me finish what I'm doing here, and then we'll go back to the book.
It's the same problem.
I know, but hold on. Hold on. This is, do I have anything miswritten here? No, it was 2x cubed here, wasn't it, in the original? Okay, I'm changing all these signs now. That's an operation, meaning subtract that puppy, that garbage. So what am I going to do? Then proceed to add. 0 minus 2x cubed minus 6x squared plus 7x, same answer. When you do long division, you will have to do what I did here. You will need the dummy variable column with the 0 coefficient. This is not an aberration. This becomes a very important thing. I'm going to leave that in the board so I can see what you're referring to in the book that seems to be contrary-wise to what I'm trying to explain. Now, in the book, in this problem, the directions are explain the mistake, then work the problem correctly. The problem, as shown, is wrong in terms of the solution. And then they ask you to explain what's been done wrong. Okay? So read your directions, which state this is an error, what should be done, and I answered the second part, what should be done correctly. Okay, let's have a little easier go of it. Something like number 86. See if I can get this book leveled out. Boy, what I wouldn't give for a hard cover to keep this nice and flat. Okay, right above the straight edge is problem 86. I don't know if that helps or not, that color sort of distracting. But you see in number 86, what would be your first step? I hope rewrite it, try it, rewrite the problem, one step, and then your answer. So I want one intermediate step, and then your solution. So I'll just leave that on the screen. One intermediate step, and then solution. Bad. Okay. So I'm going to leave that there. I think you can see what you're going to have to show for documentation for your homework. We'll just leave that on the screen for a moment while I rewrite the whole mess. Okay, that's a 5w cubed. Is that u to the third, not w? Thank you. So 5u to the third minus 4u squared plus u minus 10, close parentheses, then a subtraction of negative 2u to the third plus 4u to the second plus u plus 7. Do we agree? That's the original. Now I want an intermediate step from you. One intermediate step before the answer. I will expect that. So waiting for you to get the intermediate step. Now you have at least 3 options that we've entertained. And I'm going to go to the fastest one here in a moment for what I would hope you would do. Okay, are we to a point where we have an intermediate step? If so, here goes. Leave this one alone. 5u to the third minus 4u to the second plus u minus 10 plus 2u to the third minus 4u to the second minus u minus 7. That would be my intermediate step. Any question in that? So I have 5u to the third plus 2u to the third, which is 7u to the third. Minus 4u to the second minus 4u to the second does not cancel out. Minus 8u to the second. Plus u minus u, you're gone. A plus u minus u. You didn't see the pun. Okay, 0, and then a minus 17. You don't need to write 0u. Erica. You must have an intermediate step, yes.
What can my plus be the intermediate step when I change it?
I want this, an answer, and something in between minimum 1 step. Now, if you want 2 steps, that's okay. You didn't have to do my intermediate step.
What if instead of doing the second part of the second row, what if we put our plus sign there and just went underneath the first part that we wrote?
So you took this and put it underneath here, and then changed all those signs
Yes,
and
I
added.
did.
That's your option.
Okay.
That's an intermediate step. Okay?
Okay.
So that's acceptable. Anybody else? Okay, now that we've done all this hard stuff, I'm hoping that if I give you a problem like this, that you don't choke. Look at the problem I have on the board. Okay? Now, what's your intermediate step going to be again? 5x plus 3 minus 2x plus 1. You okay? And 3x plus 4. Otherwise, we've been working on the hard stuff, and sometimes when you come back to the easy stuff, it's like, that's not so bad. Okay. Now, Kim, on this one, I would really encourage you not to stack them. On the easier ones, try to force yourself to put it in this linear form because you just don't want to go through into the next course stacking everything. Stack for a while, but try to get to the point where you can do it without stacking. Okay, let's go back to the document cam. Now, that was a much more difficult problem. Let's back up now. So I come back center to something a little less difficult. There's got to be something that doesn't... Okay, I'll switch pages. We'll get something that's not so bad. Let's see. Okay. Something around the level of 49. Just a minute. Give me a moment, Debbie. Okay, 49. Let's look at that. Oh, curl, you dip. There we go. Okay. Now, do you need an intermediate step when you don't have a minus sign?
Yes.
Okay. So much for what I didn't anticipate. Number 49. Otherwise, there comes a point where it nearly becomes a dysfunction to do an intermediate step. On something like this, technically, you can say 10x plus 7 plus 3x. I'm wanting to say plus negative 9. I'm just going to write negative 9. No, I don't. Thank you, Debbie. Why I put that there, I don't know, but thank you. Now, what do you do next step? 13x minus 2. Do you need this step in between? I'd say at this point with a plus sign, no. I could have done this. I would be inclined personally not to, but it certainly can be done. So in something this straightforward, I don't think the intermediate step really is doing that much for us. With the subtractions, you have to. Okay, Kim first, then Sandra.
Why do you suggest not to do that with the 9 there on the second
Instead
row?
of the plus negative
Yeah,
9?
why do you?
Is it helping you?
It helps me to remember.
If it helps you, then do it.
Because otherwise I get mixed up. I think.
Okay, then do it.
Me too.
And after you've done 1,000 of them, I'm hoping
Maybe
you
I-
won't need to. So to keep from
Me too.
getting yourself confused, do whatever you need. But the key is, at some point I want you to go a little bit faster. And in order to survive, if you go into algebra, then you're going to have to be able to go 7 minus 9 is minus 2 without that intermediate. For right now, it's okay. So learning the process, take the extra step if you need. Okay, let me come off that one. When you get to a problem like this, number 5, folks, you could use the distributive property. 3x plus 9x, factor out the x and have 3 plus 9 and get 12. Just put 12x. Let's go show it one more time, Debbie. Is it acceptable just to say 3x plus 9x equals 12x and you're done? 5. Top one on the screen. Okay? Now, if you wanted the intermediate step, you'd use the distributive property and pull out the x and have 3 plus 9 left, x times 12, which is 12x. Okay. Find a balance. Okay, do we have a question? Still, Marisol and Sandra. Anything we need to discuss in the 30 seconds I have left?
I just was confused because I thought you always had to add the inverse no matter what the sign was.
Only if the sign between them is a minus sign.
Yeah, I see.
That's what you have to be careful of. Don't get inverse happy. Okay, enough with that. We have to finish or I'll be getting a call from Palomar. So we were listening to, I think, the great...